Ladies and gentlemen, hello and welcome back once again to a DM Radio Virtual Summit. Yours truly, Eric Kavanaugh, is here, and folks, we're very excited to dive into the Open Hybrid Lakehouse. We're going to talk about data lakehouse architectures, that stuff called Iceberg. We're going to talk about NVIDIA and the AI factory over at Dell. Lots of fun things on the show today. And we're going to start off with a presentation from Starburst, powering data and analytics. And I'm going to hand it over to Jay Chen to do that. And after that, we'll do our radio show. So Jay Chen, take it away.
All right. Thanks, Eric. Welcome, everybody. Yes, my name is Jay Chen. I lead product marketing here at Starburst. I just wanted to share a little bit today about how we think about powering AI, analytics, all things data using the Open Hybrid Lakehouse and what that really means. So just to kick things off, I want to start with some observations that we've all probably become very aware of in the entire industry in the market. So everyone's seen some version of this line. Every company is becoming a software company. Today, more than ever, this is really more about data and AI. Every company is really becoming a data and AI company. And what does that really mean from a macro trend point of view? There's three main things. So first of all, there's exploding data volume, and mainly due to the fact that AI and ML are going mainstream, right? This means proliferation of data sources, data types. And so naturally, data lakes have become a real center of gravity for many organizations trying to capture the value in this trend. That also means introducing a lot more complexity in existing data architectures, right? That means introducing new tools, new platforms, new systems. Sometimes that means introducing hybrid or multi-cloud environments to support these new needs of both where data is generated and where data is consumed. And that all leads to growing cost pressures. And so we're also seeing organizations look towards more all-in-one data platforms to solve some of these pain points. And finally, the importance and the criticality of these data applications and AI applications are greater than ever, right? Data is now powering mission-critical internal processes. They're driving customer experiences. And in fact, I would say data and AI is really the foundation for most tech innovation today. And that means analytical performance, query performance on the ability to act on your data is becoming extremely critical for any enterprise looking to capture this value. However, when we look at where most organizations actually are, this is a bit far from the reality. Most organizations have been built up over a long period of time, a lot of legacy data sources, a lot of new data sources distributed all over the world, oftentimes, certainly across many different systems, which leads to data silos. It leads to great complexity in the architecture. And a lot of data teams are struggling to really just wrangle and get a handle on where all their data is and how to utilize that, leading to higher costs, lower productivity, greater complexity in their systems. And this is coming from, obviously, a lot of research has been done in this area, but BCG in particular did a survey on this with a couple hundred data leaders a year ago and found this exact fact. So our point of view in order to solve this problem is really around this notion of a open hybrid lakehouse. And what that means is really implementing an end-to-end analytics platform that focuses on price performance, but also focuses on the ability to deploy and access data in both cloud and on-premise environments. And we'll talk a little bit about what this means in detail, specifically the different components of this and the different technologies involved in this. So when we say end-to-end, what we're really talking about is the entire process going from ingestion all the way to consumption, right? And there's many steps in between, and this is maybe even a simplified version of that. So when we're talking about ingestion and access, we of course want data to be as high quality as possible. We also want it to be as near real time as possible and support as many different data sources as possible, right? And then we want to land that in a location that can be easily accessed, easily managed, easily optimized for the steps that will come after that, which include things like preparation, transformations, cleanup, normalization, all those classical data pipeline tasks. And of course, you need to have governance, access control, security, privacy controls, observability on top of that data to make sure that your enterprise data isn't compromised in any way. And then you need a way to run fast performance analytics on that either for ad hoc analytics to run dashboards and reports, or to support workloads such as piping into AI and ML data training models, or even sometimes inference models, inference tasks as well. And those are often then the output is then used to either share with other consumption endpoints internally to the organization, or sometimes even external to your organization. And again, this is our view of the tasks that are needed to be serviced on this notion of an open hybrid lakehouse. So from a technology point of view, what we're seeing in terms of the industry and how organizations are solving this problem is really around leveraging open source technologies as much as possible. And so I'll talk through some of these, maybe from the bottom up, to give you a sense of some of the components in the stack, right? So first of all, what we see is a lot of it, most organizations are interested in using as much commodity hardware as possible, meaning not tied into a specific a specific proprietary hardware system, right? So this tends to mean object storage, and tends to mean elastic compute systems. On top of that, you want portable and standard file formats, right? So Avro or C Parquet. And then the most important layer here, or one of the most important layers, is maybe this open table format, which has really gotten a lot of attention over the last few years, in particular around Iceberg as kind of the de facto standard for the open lakehouse format. Of course, there are others that are important in this space: Delta Lake, Hoodie. In fact, Hadoop and HDFS are also in the picture as well. And in order to access that massive amount of data in the data lake, you of course need a query engine. And that's where Starburst and our open source version Trino come into play. We're one of the fastest, most performant SQL query engines in the world. And in fact, it was built for, or rather, Iceberg was built in conjunction and for Trino. And so there's a really nice pairing there. And that's what we mean when you hear the phrase Icehouse, which is an Iceberg lakehouse. Now, that's everything below this wavy line is really the essential data lake part of it. On top, we recognize that not all your data can necessarily be moved into that data lake. So this notion of federated access and the ability to reach data outside of the lake is also very important. And that has to happen in a very performant way as well. So we think about that in terms of providing high quality connectors and support for external data sources, as well as ingestion and stream processing. So in terms of how this adds value, we've actually deployed this exact system in several of our customers, and they're experiencing tremendous benefits in terms of time to insight, meaning accessing the data they need much more quickly, lower TCO, and as well as being able to take this open technology, open data stack, and build on top of it moving forward. So future-proofing their investment here. Okay, so I want to touch on specifically what kind of scenarios we see large organizations face and how that translates to how this technology can be applied, right? So the most obvious one, we've seen a lot of this, is very few organizations are starting from scratch, especially in the enterprise segment. And so usually they're coming from some legacy Hadoop system, and they're trying to modernize that, move it into the cloud, or build modern applications on top of that, which require a few different things that we can help on. So number one is for faster performance, we could simply replace the engine on top of that, which could come in the form of Hive or Impala, and that can immediately give you a 10x query performance without even moving data at all. Secondly, for modernizing from Hadoop to on-prem object storage, we have a great partnership with Dell, where we can literally deploy Dell appliances powered by Starburst to power your on-prem data lakehouse on modern object storage. And finally, if there is a desire to move things fully into the cloud, of course, Starburst and our cloud partners support the same architecture in the cloud fully. The second thing is, of course, data warehouses are very commonplace in enterprise data environments, and for a good reason. They're very useful, they're very convenient, they're performant. The one challenge with it is you have to move all your data into the warehouse, and that can be expensive. And that doesn't scale well when you have large data volumes or large concurrency of demand against that data volume. And so where we've seen a lot of value and where we've really helped our customers there is to move some of that large data volume off of the warehouse and into a data lakehouse. In particular, of course, we would recommend a lakehouse that's powered by Iceberg and Starburst. But in any case, it would be using the lakehouse to run the raw data ingestion as well as the data transformation pipeline. So here referred to as the bronze and silver layers in kind of the medallion architecture. And of course, you can choose to leave that gold data in the warehouse for all your reporting and analytics needs, business reporting needs, just because the interface might be more convenient there. But we could actually take cover the entire span, but oftentimes it's a choice of convenience there. And finally, this notion of accessing data where it is an important one. For a lot of times, data teams need to run ad hoc analytics, exploratory analytics, just to understand what data lives where, the shape of that data, how do we package and use that data, and they need to do that quickly without going through months and months of migration efforts. That's especially important today when the pace of innovation is just accelerating. And when we talk about AI and ML use cases, especially Gen AI, like nobody has time to wait months and months to migrate everything into a single platform to do this, right? Especially when most of your data lives, let's say, on-prem or in a Hadoop data lake, or anywhere else it might be, right? You want to access that data immediately. And so Starburst has the ability to query and integrate those data sources as if they were one, giving you fast access. All right, cool. So the components that we see that we've been building towards within this open hybrid lakehouse are the following. We see these as four main layers inside this box, which is, first of all, around data access. So we want to make sure that we can reach into all the data sources that our customers have, no matter where it is, across hybrid, on-prem, in the cloud, across object storage, and across applications. We also are supporting things like streaming ingestion that help convert raw data into Iceberg table formats that can then be managed and optimized for the analytics processes above. Secondly, obviously, when you're trusting a vendor with data access, you also have to think about security, privacy, things like that. And so governance and security is another huge area that we've built a lot of capabilities around in terms of access controls, encryption, management APIs, things like that. Above that, of course, query performance is core to what we do. And so we've put in a lot of effort into making the query engine as fast as possible in as many situations as possible. So that includes things like what we call warp speed, which is a smart indexing and caching service. We also have things like cost-based optimization, which allows you to query different sources with minimal cost and minimal data transfer. Of course, this includes more of baseline capabilities like auto-scaling, federation, things like that. And on top of that, we talked about the access layer, we talked about sharing data. And so this notion of modeling and semantic layer is very important. So we developed a offering on our product called Data Products, which is a way to create curated data sets that can be controlled, shared, managed, and documented. It can be shared within the Starburst ecosystem as well as to external consumers as well. So to put this in perspective, I won't go through this chart in every detail, but I just want to give a sense for those who are slightly more technical in the audience, how this might look practically. This is an example. This is actually just one way in which we can deploy our system. And in this case, we're taking a cloud example on AWS. And so what we want to emphasize here is that the data itself, this is the customer cloud account on the left, the data itself always belongs to the customer, right? So the data lives in a customer's data environment. It does not live in a Starburst environment. However, Starburst runs the compute that allows you to manage, optimize, clean up that data wherever it lives. And so things around, data compaction, vacuuming, retention, profiling, statistics, these are all capabilities that we have around Iceberg data management that go on top of a customer-owned data environment. And of course, all the little tiles I showed you earlier are included in these two boxes above that we also would help manage. And of course, outside of these two larger boxes, we have the federation and data access capabilities outside, right? So if you have multiple data lakes, for example, perhaps one in the cloud, one on-prem, as we talked about earlier in terms of hybrid environments, this federation capability allows you to do that as well. And of course, these all then feed into, sorry for jumping around. Of course, these all then feed into your actual use cases, right? Which could be, we talked about actual analytics and applications, but primarily of interest today, a lot of this has to do with data exploration, data preparation, feeding into your AI ML models. So with that, just jump really quickly to some use cases across industries that we've seen. And these are representative of Starburst customers across financial services, consumer industries, healthcare, technology, telco. So for example, things like fraud detection, customer 360, product analytics, marketing operations. These are all things that require massive amounts of data across different sources, across different environments, then feed into either analytics applications or AI-driven applications for these Fortune 500 customers. Just a few stats here. I won't hang on too much, but essentially our customers are seeing tremendous performance improvements, cost improvements, and efficiency and productivity improvements when implementing this notion of an open hybrid lakehouse with Starburst. And when we think about our approach to building product and helping our customers, we really think about these four things. It's about simplicity, making it as easy as possible and as quick as possible to go from raw data to insight and decision. We think about access. We want to help customers ensure that they can always access their own data wherever it is and make that a very easy but secure and governed and a contained experience. We also think about scalability. We know that data volume is only going to grow. And so we want to make sure that as that data volume and the data demand grows, we can support those needs at a very cost-effective way. And of course, optionality is very much core to what we do. We don't ever want customers to be locked into a proprietary environment. And so everything we do has the backdrop of can we keep this open source or build on top of open source? Can we make it such that customers can choose what tools they want to use, what data, what file types and table formats they want to use, and make sure that it's portable for that customer if they find a better solution out there. And so with that, I just say thank you for your attention, and we hope you give us a try. Thank you very much.
That's great, Jane. Real quick, before we do the radio show, we have a great question from an audience member who writes, does it mean that Trino becomes your data service products aggregator? I mean, you kind of spoke to that for a minute, but real quick, you want to answer that?
Yeah, absolutely. So Trino is really at the heart of everything we do, because Trino is the query engine. And so when you think about all the activities that you're doing on top of your data, it has to go through some kind of processing, right? And Trino is at the heart of that. So in a sense, yes, but Starburst also builds on top of Trino with a lot of unique features, such as, for example, the ease of use piece of it, right? Deploying anywhere you want with a click of a button, all the governance and security, access controls, right? Encryption, all those things that are just done for you. Auto scaling, right? Warp speed, again, like the whole thing around caching, indexing, those are things that normally, if you were to deploy Trino on your own, you have to set up a whole, caching architecture, and it's quite complicated actually. And so we try to take a lot of that complexity away for the customers.
Well, that is fantastic. All right, folks, we're about to begin our radio show. Great presentation by Jay Chen. Thanks so much. And Jay, I'll push you down to the attendee role. And we do see a raised hand out there, so we'll get to your questions in a minute. Let's stand by 1 second. All right.